This webinar is about the LED, the Vivacity LED Safety Tactile. It's being demonstrated at a site in Melbourne, and through this webinar we will give you some more information about some other studies and show you with a hands-on demonstration exactly what comprises LED Safety Tactile. My name's Dave Jones. I'm the Director of External Affairs for SmarterLite and Vivacity, and my background is in traffic and transport, and co-presenting with me is Gary Kemain. He's the CEO of Vivacity Traffic Communications for the SmarterLite Group, and he's the project lead for the Melbourne demonstration site and has overseen the technical development and improvement of the LED Safety Tactile. There's no one in the world that knows more about these tactiles than Gary. So the structure of the presentation is that we will give a brief introduction to the SmarterLite Group and Vivacity. We will explain the LED Safety Tactile. We'll demonstrate aspects of it, including installation, connection, and different applications of it. We'll discuss the South Korean research, where there are many LED safety tactiles installed. We will discuss some research and findings from the Melbourne demonstration site. We'll provide our contact information if you need more to assist you, and then we will have Q&A. So please use the Q&A function if you think of questions during the webinar, and we will answer them at the end. So briefly, Vivacity is part of the SmarterLite Group. The SmarterLite Group is about making your roads, buildings and infrastructure safer, greener and better. Vivacity, of which Gary leads, is a specialist a provider of high efficiency, low energy LED lighting for buildings and infrastructure. For example, the LED Safety Tactile is just one of those innovative pieces of technology, as well as things such as the parking meters in the City of Melbourne with the rotating blue text at the top showing the location of the meters is just another local example. And Gary's technology is also in many bus shelters for the advertising panels and lighting across Australia. Also part of the SmarterLite Group is SafetyPath, that is a world leader in environmental lights without electricity or batteries, using photoluminescence for high-performing, energy-saving exit signs in buildings, as well as many applications in paint and signs as well. And finally, OmniGrip Direct is specialist in recycled and natural aggregate safety surfaces for roads and buildings, so green bike lanes, red bus lanes, and high friction surfaces to reduce skidding and crashes in black spots are just some of the examples of the technology that we provide. So with that, I'll hand over to Gary to talk through what is a LED Safety Tactile and give you a demonstration of the technology. Over to you, Gary.
Okay, thank you, Dave. Hi everyone, my name is Gary Kemain. Today I'll be talking about what is an LED Safety Tactile. I will show you some images of various tactile installations. I will go through the specifications of the tactiles. We will look at how the tactiles are installed. I will show you some other applications where the tactiles can be installed outside of traffic controlled intersections. And then I'll give you a live demonstration of the tactiles. So I will now share my screen and we will go through my presentation. Okay, what is an LED Safety Tactile? The LED Safety Tactiles are designed to significantly reduce the risk and number of injuries and deaths at intersections with and without traffic lights. They reduce the likelihood of distracted pedestrians not looking up from their smartphones before stepping onto the road. The tactile blocks are installed in roads on the curb side of the intersection, as you can see on the left, on the right-hand side. They can be connected to the traffic pedestrian lights, shine in the same color as the pedestrian lights to create awareness of the signal change at the intersection. This basically means when the little green man is green, our tactiles are green. When they're red, our tactiles are red. When they blink, our tactiles blink. So they exactly mimic the pedestrian lights. This makes pedestrians are more cautious of traffic, have quick awareness of signal change without having to look up Look at the small green man across the street. People with vision impairment, mobility impairment, find it easier to see the LED tactiles in the ground at their feet rather than a small green red person in the pedestrian lantern across the street. And also drivers can recognize the crosswalk light change at 30 meters distance at night, adding to the visibility of the crossing and the safety of the pedestrians. What you see here are various installation images in Korea, where the technology was developed with our partners in Korea. As you can see, we can go across the whole length of a crossing. We can go with maximum is 24 tactiles across one length. If you look at the bottom left-hand corner, you can see we can also curve the tactiles around a curved corner. And you can see here, we have 2 arrows incorporated into 2 separate tactile blocks. This is to help people who might have color difficulties, and they can see the outline of the arrow, and it shows when it's safe to walk. These little arrows can be incorporated into any tactile along the intersection. This is the intersection that we have done in the city of Melbourne. The client was TAC and Vic Roads. As you can see, this image here was taken in daylight, and as you can see, the tactiles are very visible in daylight. They've been designed to work in day and also at night. The image you see here is the same intersection. On the right-hand side, this is daytime, and on the left-hand side, you can see the nighttime image. What we've done here is that when we supply the tactiles, we also supply this device here, which is the control box, which you can see is fitted onto every pole at every section of the crossing. Inside this control box, we have what we call ambient sensors that pick up when light drops, so it will dim the tactiles accordingly. So at dusk, these lights will dim down to about 70%. It drops by 70% of the daytime brightness level. This is all controllable, but this is the brightness level that was determined and decided by DOT at this installation. So what is, again, a tactile block? It's basically the exact same as a standard TGSI. It has the exact same dimensions as the TGSI, which is 298 by 298. It has the exact same number of bumps as the TGSI, which is 36. The height and the circumference of the bumps are the exact same as the standard TGSI. So it is a TGSI, but with our added technology inside it. The tactile itself is rated at IP68. The slip resistance is 59 ppm, when the standard is 40. The tensile strength is 60.7 MPa, which is about 20 ton. So these tactiles have been tested to handle an emergency truck driving over them. And for the city of Melbourne, we have this truck, a street cleaner drives over 3 times a day. So we can handle basically any kind of punishment you put towards it. The tactile block comes in 2 sections. We have here, you can see the base plate, and on the right, you see here what we call the LED top plate. We supply these parts and also the DC cables. The voltage, it's 24 volt DC, so there's only low voltage in these devices. The power consumption of each tactile is 4.8 watts, so it uses hardly any power. So how do you install the tactiles? This is the install we did in the city of Melbourne, where we had an existing tactiles in the ground, non-illuminated. So basically what we did here is we just cut around these tactiles. We dug them out. You have to go down about 60 millimeters in depth. We then lay a bed of cement onto the base. We fitted our base plates into it. And then, as you can see here, we fitted the tactiles. Each of these tactiles has its own DC cable. We supply all the cabling to join the tactiles together, and also to connect, as you can see here, through this wire up the conduit, up the pole to the control box. So we supply all components that's required to connect these tactiles to your pedestrian lights. In a new situation, like you can see here, where there's no tactiles before, we just dig out the substrate, whether it's concrete, asphalt, whatever it does be. We again lay a bed of sand. We then put our base plates into position. And as you can see here, we are connecting the DC wires, and then we lay the tactiles on top. Very simple installation. This shows other applications where we can install our tactiles outside of traffic control applications. So the image on the left-hand side, you will see a zebra crossing. So what we can do in this situation is that we can just take the existing tactiles out, put our tactiles in, and we can make them blink orange. This can be in a rural situation. We can also have these where we have proximity sensors here. We can pick up if someone's in this area. It can turn the tactiles on so it blinks for a certain period of time. This could be solar controlled if you had no power. So it just gives the driver will know that as he approaches this intersection or this crossing that someone is about to cross. So it enhances the safety of the zebra crossing area. The image on the right-hand side is of a tram stop in Melbourne. What we're doing here is showing what we could do in this situation. This gentleman standing here on this tactile would normally cross over the tram lines to get to this side. He will visually obviously look to see if there is a tram coming. What we could do here in this situation is we could put our LED tactiles in here. We could have a tram track detector system built into the tram tracks that we could detect this tram is coming. It would then activate these tactiles, which would blink red. So this person would know there's a tram approaching and he would not cross the intersection. When the tram has passed, this tactile would turn off and default back to being a standard TGSI. Other applications, well, look at the right-hand side first. This is a project we're doing with a European manufacturer of escalators. Again, it's a huge problem there where people do fall here or they go down the wrong part of the escalator. So what we're showing here is that two things we can do with our tactiles here. We just have them, they will blink green, which means this is the way you should be going, and red where you should not be going here. This is up and this is where we're going down. We can also, with the tactiles, illuminate certain parts of the tactile. So you can see here, we can have green arrows showing this is the way you should be going. And obviously here, this is the way you should not be going. This could also be an X, not just an arrow. On the left-hand side, you can see an application we're talking to where we could use them on train lines. So as a train is approaching the platform, you know, everyone knows this yellow line means stand behind the yellow line. This line, you know, sometimes gets worn or people don't pay attention to it. If we put our tactiles here, we could actually make these tactiles blink yellow, which means, you know, stand behind the yellow line. People who are looking down at the phones and not paying attention can clearly see there's something about to happen. What we can also do with these particular platforms is that we can put these arrows here at certain parts of the intersection, say this tram line, when the train stops, which will stop where the doors are, which will show it's now safe to enter the train. When the train doors are about to close, we could make these tactiles go red, which means, you know, doors are about to close, warning. So there's lots of things we can do, and we can customize things to suit what the customer requires. Okay, this is what a tactile looks like, but I'm now going to show you a little demonstration. So I'm going to just turn off my presentation, and I'm going to show you what these tactiles look like. So hopefully you can all see me again. So this is what our LED tactile looks like. We have our top LED plate, and on the bottom we have our base plate. They're designed so that the base plate is permanently fixed into the ground, as I mentioned before. If there is a problem, we can, with a special tool, we can remove the top plate and it comes out, give a bit of force here, and it pops out. So the base plate will stay there. As you can see, we have a tiny little DC connector here. This is connected to the main cable that's built into the base plate. So we can quickly unscrew this. We can connect the new tactile, and very, very quickly, we can just fit this thing back in, reseal it, and it takes about 15 minutes, one person, to change a tactile if you ever do have a problem. This tactile, as you can see, is white in color. This is a color that the City of Melbourne chose to blend into the bluestone pavements. We can, of course, make it yellow as well. Or, you know, the standard colors are yellow and white, but we can obviously do other colors, but that's a customized project. What I'd like to show you now is what the LED tactiles look like. So this is how they look normally. As you can see, they're green. Someone has activated the tactile button to cross the street. Once it's over, it goes back to being red again. So they're always red until someone actually pushes the button and it goes green. When they're on the ground, these are extremely visible, as you can see. And Dave, that was my very fast and very short description. I hope you all found that interesting and informative. I'll now hand you over to David.
Wonderful. Look, thank you very much for that, Gary. It was a good demonstration and it went well, I think. Again, if you have any questions, please use the Q&A function and ask them, and we will go through them at the end of the presentation. So what I'll talk about now is some of the different studies that have been done that have evaluated the LED safety tactile. So starting out is with the South Korean program. They're extensively installed in South Korea. As Gary explained, that's where we worked with the South Korean company developing and refining the design of the LED safety tactiles. They're used at both signalised and unsignalised crossings. So, for example, the top image on the right there is something like in Melbourne, Flinders Street and Swanston Street is what we call a scramble or a Barnes crossing, depending where you come from and what you may call it. South Korea has something similar where pedestrians can cross in any direction. So it's an all red phase for vehicles and pedestrians can walk from any corner to any corner. And they're used on that type of intersection. South Korea back in the early 2000s had quite a problem with crashes, particularly with pedestrians at night. So the technology was originally developed as a pedestrian safety measure at night. 40% of road crashes were with pedestrians at night. 65% of crash deaths were pedestrians at night. So 1,345 pedestrians were actually killed in South Korea in 2008. At night, and the city that we'll talk about in evaluation was Changwon City, where 60 people died in pedestrian crossings, pedestrian crashes, with 40 of those being at night, so 2/3. And from reading that study, it refers to a Korean Transportation Safety Authority study, which was looking at ways of improving pedestrian safety at night, particularly for older pedestrians using unsignalised crossings, and ways to improve the visibility of the pedestrian and the attentiveness of the drivers approaching the pedestrian crossings. And they recommended and tried various things before LED safety tactile. So they improved the lighting on the crossing, on the area of the roadway. They use like a bollard or a pole on the sides of the road. You may have seen them if you travelled in different countries. They have like a sturdy sort of bollard with a light in it, and they tried increasing the brightness of those, and there were all sorts of problems, including not being effective or dazzling the drivers with shining bright lights towards them. And eventually they landed on the LED safety tactile, and the study says LED safety blocks, as they call them, are installed at the starting point of the crosswalk, enabling a driver to detect a crosswalk that's more than 30 metres up ahead during night time of reduced visibility and notice the pedestrian at the pedestrian waiting zone. For pedestrians, LED safety blocks serve as a psychological line to alert them to nearby vehicles before crossing, further reducing the risk of accidents. So they were developed as a pedestrian safety measure, both to alert the pedestrian and to alert the driver to the presence of pedestrians on the roadside. And it all came from a study looking at the safety of older pedestrians. So the South Korean evaluation, and it's on the right-hand side, it was by two universities. The authors were Park, Yu and Choi. It was published in 2014, but it looked at changes in the 2008 and 9 period. It specifically looked at 22 crosswalks with LED safety tactiles, like the ones shown in the images. They're actually from the report at the bottom of the screen there. And it considered 12 months before and after crash data and considered crashes within 30 metres of the stop line. So they're quite busy urban intersections, but they're unsignalised pedestrian crossings, which is why they're yellow LED safety tactiles versus the red or green that are connected to the traffic lights. And the study is available from the authors, obviously in Korean, but we're working with a recent English translation by a native Korean speaker. So the study referred to both a survey of perceptions of safety for pedestrians and an actual crash study. So just some of the findings, this is directly from the report itself, are about perceptions of safety. So are you sure these blocks contribute to pedestrian safety at crosswalks? And this is asking pedestrians on the street. 351 positive responses and 47 negative, so nearly 400 respondents. Do pedestrians perceive that they contribute to crosswalk awareness by drivers at night? 364 positive and only 34 negative. And do you think the installation of the blocks help pedestrians? And 368 positive and 30 negative. It was interesting that I didn't have the breakdown of male versus female, but nearly 75% of the respondents were actually what they call the teens and 20s. So look, for this I've said 13 to 29 would indicate teens and 20s is how we would classify them, age bracket in South Korea, but they did describe them as teens and 20s in the report. So it may be slightly older than 13, of course. Looking at crashes, this chart sums it up quite nicely. So the installations were in the latter part of 2009. There was a clear decrease in crashes post-installation, a decrease in crashes, injuries and deaths at the treated locations, and the study looked at crashes elsewhere in the city and the country and found there was overall increases at other locations across the country. So at these specific sites, there was a 41% reduction in traffic crashes, 39% reduction in injuries, and 55% reduction in fatalities. There was a positive net present value analysis, and the BCR was 56. So the benefit cost ratio is 56, which is an amazing result. But you can see quite clearly in the chart this significant drop in the number of traffic crashes, the number of injuries, and even though the number of deaths is comparatively small compared to the rest, there was a 55% reduction in fatalities afterwards. Now, the Melbourne demonstration site, it wasn't selected because there was a crash problem, so there isn't a comparable crash study for Melbourne. It was picked as a demonstration site. It was picked because of the volume of pedestrians and how it would be seen by a wide number of people in central Melbourne near the town hall on Swanston Street. And it's not necessarily a typical location, so there's not the same. It's not a high crash location like those South Korean sites, and therefore there's not the same sort of evaluation. So we were thinking about what we could do just to test perceptions of safety, much like the South Koreans did. So we did a similar small survey. We did ours online and had 82 responses in a short period in December 2019. We used Facebook and LinkedIn to test perceptions of safety. And we targeted people in central and inner Melbourne. And in the case of LinkedIn, because it has these features, we excluded people that had identified themselves as employees of the Department of Transport, Vic Roads, Regional Roads Victoria, City of Melbourne and Transport Accident Commission. They were all and obviously our own employees, because they were people that are directly involved in the project. And of that small online survey, we had 75% male and 25% female, so that wasn't characteristic of the population. But there was a good age distribution in terms of the number of responses, and this was quite different to the South Korean study, which was mostly youth, as we saw, that responded. We also looked at social media that we'll come to shortly, which identified a lot of people who were short-sighted and had other sight-related issues when we developed the survey questions. So we asked people did they have any conditions that might affect their sight, for example, and you can see the questions, or whether they had other mobility impairments that might influence their thinking, and you can see that 35% of survey respondents said they wore glasses or contacts. Yet the Australian Institute of Health and Welfare, we found says that 55% of the Australian population has sight issues. So our responses may not represent, as in they may underrepresent the perceptions of people that have some sort of sight impairment. So from the questions, we found 68% of respondents said that the LED safety tactiles in the footpath at an intersection with traffic lights made them feel better. And that's obviously a great result. It's a consistent positive response with what the South Korean study found. So it clearly has some benefit for people walking, that they feel safer when these tactiles are at an intersection. 59% said that the LED tactiles are easier to see than the standard red or green person light across the road. And this is a really important finding for us. And you know, if someone had to come up with designing the way of controlling traffic and pedestrians at an intersection now, with what we know about human factors and involving people in design, you wouldn't put a small red or green person light on the far side of the road as a visual warning to pedestrians that it's not safe. It's just not a human-centered way of designing or controlling the movement of people across a hazard like a road. The LED safety tactile is a good way of bringing a much bolder, a much larger visual signal to the same side of the road as the pedestrian, and it reinforces the beep from the traffic light control button as well, which is the audio signal. But this brings a big, bold visual signal to where the pedestrians are actually standing on the same side of the road. It doesn't rely on people to look through the traffic across, in some cases, very wide rows to see a very small symbol. Given what we know about people and the differences in abilities in cognitive thinking. So we think this is an important response from our survey question. And 41% of people said the lights alert them when busy using a phone or listening to music or chatting to friends. And in road safety circles, we often call this distraction, distracted from the task of being a pedestrian or walking or focused on driving. But if you think about an urban area, cities are designed to distract. That's what makes them thrive. That's what makes them work. That's how every shop and all the experts that design shop front displays and signage for shops are all trying to get someone's attention so they spend. So cities are designed to distract people, and that's part of what makes them cities. So we need to come up with ways of helping people be safe that accommodates or acknowledges the fact that their attention is not going to be on how do I walk safely down the street. They're going to be socializing, talking to friends, talking on the phone, sending messages. We'll do it, let's face it, we shouldn't deny that. Listening to music, that's what part of an exciting city is. And this is a way of helping people be safe while they do what they really want to do, which is enjoying the city itself. And we also asked people whether they should be used more broadly, and 30% of people said they are helpful and every road crossing should have them. Now, we're also the beneficiaries of some great social media, and we all looked at many of the comments. So just for example, obviously the Premier of the state of Victoria in Australia, Daniel Andrews, has put out a TikTok post, which is great if you go and listen to it. The music is timed beautifully, as well as Facebook type posts, and had 27,000 likes and huge number of shares, 600 shares on that one, and 2,400 likes and 826 comments on that one. And there was another LinkedIn post by an IT professional who saw them, which received an astonishing 270,000 views of his video as well. And we went through a lot of the different LinkedIn posts because they have good comments and informative comments on them. And just, you know, for example, I put some on the screen. So people saying these are useful. I've taken the first step many times with the sound without realizing a second later that it wasn't their light. Vision impaired people benefiting, the one on the top right there by Charlotte. It helps a variety of people, hearing impaired, vision impaired, because vision impaired doesn't mean obviously blind, many people can see. And they might just need something that's brighter. For people in wheelchairs that can't see, we've had several comments, and people have spoken to Gary directly. People in wheelchairs can't see through a crowd to see something like a light because everyone's bodies and heads are in their way. They need something which is down low for them to see. and respond to. So there's been some positive responses, and another one on the bottom right there about small children being able to recognise, understand what it means, and ones that haven't learned to look across a road to look for the red or green person light. And even my own daughter has said to me that she loves them because she's fashion conscious, doesn't like wearing her glasses when she's out, she's short-sighted. She can see these, she struggles to see across a road when she's walking by herself. So to sum up, as cities are designed to distract people, that's how retail works, that's how cities work. And these are what we believe is a human-centered way of bringing safety and good design that can be easily retrofitted to traffic signals anywhere. They can be used on unsignalised crossings as they've been evaluated and have been used extensively in South Korea, as well as signalised crossings like the Melbourne demonstration site and the South Korean examples as well. They can be used at tops of escalators. They could be used on light rail and tram and train corridors with the different types of pedestrian crossings. Metro stations, there's many different applications where it's important to give people a visual signal to reduce risk and to make it easier for people to go about doing what they do safely. So it's about getting the attention of people that are enjoying the city and so they can do that experience and enjoy that experience safely. Gary's contact details are on the screen if you would like more information, his mobile number, as well as his direct email address, or you can obtain more information by visiting our website.